Hi guys, welcome to 5mantra.com. This is Kalyan, okay, in the Faculty of Aptitude, and we are going to discuss about the combination of 6 circles on today. Let us see what the shade area we have to find regarding 6 about in the combination of 6 circles. Now let us see the one more technique of the combination of circles once again. I want to tell you once again what the thing we have done for 3 circles and 4 circles. The same thing we are going to do with the 6 circles also. How many circles are this? 1, 2, 3, 4, 5, 6. This is a combination of 6 circles. And here we have to find out the area bounded in between the circles, means shaded, red colored shaded region in this case also. In this case, you are not asked to find out in terms of simplified answer, directly we can do like this. Okay, now here once again I am repeating, and before starting the problem, once again I am telling you guys that our intention, our motive of starting this channel is that only this content of competitive examinations, especially the chapters like mensuration, geometry and trigonometry, these are like very difficult, difficult chapters for the non-maths background students, for commerce background or for biological background students. These chapters are very difficult and they are very poor at their skills. It is not their mistake, because it is not their core, they can't do these problems. Even small basics also are unknown to them. Considering them only, this content should reach to each and every one throughout the country. That is our target. For that reason only I am going a bit slow, and in further we are going to conduct the live sessions. In live discussions we will go a bit fast, because there only our intention is to complete the question and answers. Once again I am telling you, here our intention is to make the concept understanding the all students, maximum students of non-maths backgrounds of all languages, all states in the country. So that's the reason behind I am going very slowly in the explanation. It should go to everyone and everyone should be benefited. Then we will feel very happy. There will be a benefit of our, we feel very much happy if it is benefited to them, all the non-maths background students also, to crack the examination of SSC CGL. Nowadays government job is very required for everyone, very much required for everyone. So to crack the government job, especially to crack the staff selection commission, these topics are deciding factors that everyone knows. So my intention is, slowly I am teaching, only my intention is to reach this topic to all those non-maths background students of all languages. So kindly maths students, don't be hurry and don't get the boredom while teaching the problems. As we are going to the higher end applications, we will go a bit fast. Okay, here more important thing is to understand the problem than solving. Obviously you can solve the answer if you understand the concept very well. So I am going a bit slow. Why I am telling you once again all this? Because math students may get the boredom a bit. Don't feel that, because we are the teachers here. We need to consider each and every student, whether the student of maths background or non-maths background, all are same in according to us. This content should reach to maximum non-maths students also, and they may also get the jobs based on these topics, because this topic carries many more marks. And after this, geometry techniques also we are going to give. Okay, let us start the technique. Let us look at this now. How many circle combination is this? Same as the previous cases. Now here these 6 circles are arranged in such a way that each circle is touching remaining 2 circles. See, this circle is touching these 2, this circle is touching these 2, and this circle is touching these 2. So every one circle is touching other 2 circles in such a way that this arrangement is done. In this case, again we need to find out the area in between the circles, I mean, according to the diagram, they said that red colored shaded region. So what we have to do? Again, same analysis as before, some problems. How to do? First of all, select the centers of the circle and join them together. Let us see what the figure is formed inside. See. Let these all be the centers of the circles. Joining them all. And it is said that all the circles are having equal radius. That means all are capital R only. So this is what? So all are capital R's. That means each side is working on length of each side is R plus R to R, R plus R to R, this is to R, this is to R, this is to R, this is to R. Means while joining the centers of the all circles, all adjacent circles, what the figure is formed inside? It's a polygon of 6 sides. Means 6-sided polygon is formed over there. 6-sided polygon in the sense 1, 2, 3, 4, 5, 6. Total 6-sided polygon is formed. And 6-sided polygon is nothing but hexagon. And one more thing. Here in hexagon all the sides are equal or not? All the sides are equal. When in hexagon all the sides are equal, all the angles also would be equal. All the angles are also equal. Means a polygon with all equal sides and all angles equal and all sides also equal is called regular polygon. In this case, this is hexagon. So how can we call this? How can we name this? It's a hexagon or regular hexagon? It's a regular hexagon. Regular hexagon in the sense all the sides are equal and all the angles are also equal. Such a hexagon is formed. Same as the previous cases, let us separate the diagram and arrange beside this. Separate the required portion from the diagram to avoid the confusion and arrange beside this, and let us see what happens. Now I am separating this section, portion, and I am arranging like this. Is it looks like a benzene ring or not? If any chemistry students are there, they can understand this looks like a benzene ring in chemistry. Okay, that's not a topic. Now let us move into this. Now this is a regular hexagon. Each side is 2R, 2R, 2R. Actually, I haven't drawn it like a regular hexagon. That is my drawing skills, but it is equal. Consider these all sides are equal only. Means all are equal sides. This is regular hexagon. Now in this, what are the blue colored portions? Like this only, no? That's it. Now I mean and we need to find out the area of this shaded portion. Is that right or not? Is it look like this or not? That means we have to separate the cross section, or we have to separate the region which is required from the given diagram, avoid remaining all. Now what we obtained? It's a regular hexagon. From this regular hexagon, the 6 unshaded portions are there. If you from the area of the regular hexagon, if you subtract 6 unshaded portions, you get the shaded region or not? That's it. So here regular hexagon, so we need to have the awareness towards regular hexagon and what are the shapes. Again we see, suppose I will separate one. Is this a sector or not? Sector only. And let me remind you that according to geometric properties, now I don't explain why it is angles 120 degrees, but in geometry it comes to know. But now for doing the problem, what is the each angle in a regular hexagon. Each angle in a regular hexagon would be 120 degrees. Each angle would be 120 degrees. Let me write this with some different colors so that it can be identified. 120 degrees. So what we did here, what we analyzed till now, here each unshaded portion is in the shape of sector, means sector representing a sector, and radius of sector in all the cases is capital R, because as it is given in the diagram that all the circles are having equal radius, and that would be capital R. So here radius of each sector also will be capital R, and all the sectors angle would be nothing, sector angle is nothing but regular hexagon angle. Regular hexagon angle, all the regular hexagon angles are 120 degrees. How it is I don't tell you, because that's the that comes from geometry. If I explain you that, the topic will be deviated. So consider for doing this problem right now that each angle in regular hexagon is 120 degrees, and radius of each sector is capital R, and side of the each side of the regular hexagon is 2R. Understood or not? So these are the details we found. So what we have to do finally, we have to subtract the area of 6 sectors from the regular hexagon. So for that we need one more thing, that when we have given, I have to tell you one more thing, that so here we need to understand one more thing, that when side of each regular hexagon is A, then its area would be, regular hexagon area would be 3 root 3 by 2 A square, where each side of regular hexagon is A. This how it is possible, that will be explained to you in the regular lesson. These are the tips and techniques. So I am telling you directly, if each side of the regular hexagon is A, like that, then what is the area of the regular hexagon? Tell me. 3 root 3 by 2 A square. Remember, now we do the continuation of the problem. Okay. As we know, the area of the regular hexagon is 3 root 3 by 2 A square, where A is a side of the regular hexagon, and we know that the angle of the each sector is 120 degrees. Okay, and each side of the regular hexagon is here 2R. First of all, let us find out the area of regular hexagon. Area of regular hexagon, that is what? 3 root 3 by 2. Here A is 2R only, no? So 2R whole square. Right? Now let us simplify that. What it is? Now 3 root 3 by 2. 2R whole square would be 4R square. Now 2 can cancel 2 times. That is 3 root 3 in that sense, 3 into 2. That is 6 root 3 R square. So we obtained the area of regular hexagon in this case. Once again telling you, for those who don't know about regular hexagon, area of the regular hexagon is 3 root 3 by 2 A square, where A is a side. Here A is 2R. We substituted 2R in place of that, and we obtained what? Area of that as 6 root 3 R square after final simplification. Now let us do the continuation. Now we need to find out the area of each sector and make it to 6 times, because each sector angle is 120 degrees and each sector radius is capital R. So all the sectors are equal, and we can find out the area of the each sector. We can make it to 6 times of that to get all sectors area. Now let us find out the sector area. Okay, to find out the sector area, what the things are required? Central, area sector angle means central angle made at the sector. So what is center angle? Each sector angle 120 degrees. And what is radius of each sector? This is r like that as given in the diagram. So each sector radius is capital R. Okay, so here capital R is the radius of each sector and angle made is 120 degrees. So each sector area would be how much? Okay, each sector area equal to what is the theta by 360 times of pi capital R square. What is theta here? 120 or not? Theta means angle. What is that? 120 degrees by 360 times of, okay, pi r square. Pi here radius is capital R square. Now further can be simplified to 121s are, 123s are. Now what it is? 1 by 3 pi r square. Okay, so what the results we obtained till now? What are the results we obtained till now? Area of the regular hexagon is, area is 6 root 3 r square, and area of the each sector area is how much? 1/3 pi capital R square. Now what is our next step? We have to subtract hexagon area minus 6 sectors area. All the sectors are equal. So what we have to do? What is our next step? So area of the shaded region is equal to area of the regular hexagon minus area of the 6 sectors. So shade area equal to area of the regular hexagon. What is that? 6 root 3 r square. 6 root 3 r square minus here each sector area is 1 by 3 pi r square. How many such a sectors are existing over there? 6 sectors. So 6 sectors area means 6 times of this area. 6 into 1/3 pi r square. Now 3 cut 2 times. So here this is how much? 6 root 3 r square minus 2 pi r square. I think 2 r square can be taken common out of this. If you take common like this, 2 into 3 root 3 minus pi into r square. Is that right or not? Let us see, verify. 2r square is multiplied, 2 3s are 6 root 3 r pi r square, and when 2 multiplied, 2 pi r square. So is this answer or not? So your final simplified answer would be 2 into 3 root 3 minus pi r square. Pi times of r square. So this is analysis. Once again I am telling you, don't think that this process you need to do in the examinations. This is just a process of analyzing before while doing the practice. If you don't know the reason why to apply this 2 into 3 root 3 minus pi r square, what is the use of knowing that? Unless you understand the proper process, you can't remember for a long time these shortcuts. Once you understand, now you got it. Now I will give you the exercise based on this. While doing the exercise, it comes to know that how shortest answers we are getting, how shortest process we are involving. Why? Because once you analyze like this, if you keep that result in your mind, then it's within fraction of seconds you can get the answers while doing the problems. Don't follow the shortcuts initially. Follow the procedure. Know the reason. Understand the concept. then obviously you can understand what is the shortcut in that and apply that shortcut while doing the problem. That is my question. So finally what we obtained? Finally, what is our conclusion? When 6 circles of equal radius, that means 6 circles, congruent circles, are arranged in such a way that each circle touches another 2 circles, then the area of the space or area of the plane in between them, in this case this red color region, is finally what is the answer we obtained? Is 2 into 3 root 3 minus pi r square. Now whenever you are given that, suppose in this case they'll show you diagram like this, and they say that each radius of each circle is given as some 4 centimeters, and you find out the area of this shaded region in between. Then how do you find it? Don't involve the process which I said. Okay, that process is only for the sake of understanding. If you once understood, leave that. Once you understood means concept is there in your mind. Now you don't follow that while doing in the exam. Now just follow this. What can you do here? Radius is given as radius of each circle is given as 4 centimeters. Now you are asked to find out the shaded region, this region, red region in the sense is a region between the circles. Then what we have to do? Simply have to put the value of r in place of that, you get the answer. So what is the value of r? Let us suppose radius of each circle is given as 4. Then put 4 here. Then what do you get? 2 into 3 root 3 minus pi times of what? 4 square. Simplify this answer. 4 square is 16. 16 2s are 32. 32 if you want to further multiply with inside also. 16 into 2, 32. 32 into 3, 96 root 3 minus 16 into 2, 32. 32 minus 32 pi centimeter square. Like that we can get the answer or not? That means while doing the analysis only it will take some time. That is at the time of preparation. It will take some time. Once you completely understood the problem, while doing the exam, you don't get that much of time if you properly understood that. But to understand that properly, it will take lot of time. Once you understand, this is final answer. Hope you guys understood this problem.